All right, well, we'll go ahead and get started for the session. Have the dubious distinction of being one of the last sessions on the last day, so appreciate you guys being here. Hopefully it'll be useful and informative. My name's Craig Reynolds. I look after the government solutions for Keysight Network and Application Security Group, previously part of AFCEA products and solutions, if by chance any of you are familiar with AFCEA. I wanted to start off with just a couple of kind of slides, a couple of minutes on who we are and what we do. I think it'll give you kind of useful context for where we're coming from for the rest of the discussion. Keysight's been a leader in the test and measurement industry for well over 75 years. We sell to enterprises, service providers, network equipment manufacturers, and of course government organizations all over the world. Obviously, from a U.S. federal perspective, we've got all the ATOs, DODN, APL, FIPS, of course from a sourcing standpoint, TAA, et cetera, to make sure that the products and solutions are successful being deployed, and in procurement, as well as the teams in terms of technical capability and clearances if necessary to come alongside in the deployment and make sure that that's successful. Really two key areas that we help our government customers with, network modernization, network fortification, clearly not mutually exclusive by any means, and just for the sake of time I'll kind of blow through this particular one. But there's really kind of two key, I'll say, approaches we help customers with, right? So this amazing amount of, I'll say, promise of new technologies, whether that's 5G on the communication side, the power of cloud, what we sometimes refer to as sort of the internet battlefield of things. There's these amazing new technologies with the promise of making the modern warfighter much more effective and efficient at meeting the mission. But it also introduces a lot of complexity, potentially blind spots in the network. And so that's where Keysight comes in to first on the validation and test side. We help make sure that those network technologies, maybe a network element, a network system, whatever the case may be, is going to be able to, for example, interoperate, but that it's going to perform and do so securely the way you expect to before you actually have an issue and see an issue, right? So we'll be able to hit it with everything from traffic generation to high-scale applications that should be running on that network, and to see how it performs, to malware, threat, and kill chain scenarios to make sure that it's secure and the security teams are able to respond the way that they need to even introducing error, right? So jitter, latency, lag, and is that network system or element going to respond and recover accordingly to what you expect? So that's the validation side, making sure you're successful on the front end. And then on the visibility side is, again, I already mentioned, but these new complexities can introduce a lot of blind spots, and then you don't have the right data, in our case, focus on packet data, going to the right teams, the right time, and the right tools, and in the right conditions. So we help make sure that those, and again, for a focus area for this conference, security teams and tools have all the information they need to quickly identify any issues, mitigate those issues, and of course remediate the situation. So that's where we're coming from at a very high level. Obviously, hopefully you saw from the introduction that we're focused more on the visibility side of that spectrum today, and just a very simple kind of framework, kind of abstracted at this level of that concept of getting all of the different data inputs, very distributed, very diverse sets of data from across theaters, across domains, regions, however you kind of want to think about that. In this case, I'd represent by the enterprise network, the tactical and operational edge, maybe the tactical or strategic cloud. But wherever that data set and the sensor assets are to send the data, getting that in through the visibility fabric that I'll mention more about here in a moment and kind of walk through a reference architecture for, and then on to the tools that need them. Of course, the conversation today was about getting it to these sort of centralized analysis platforms, and that's what we represent here. Just some examples. That could be, big data for AI and ML and some of those sorts of analytics. It could be local CPTs, maybe troubleshooting teams, whatever the case may be. And again, I've represented a sort of a box that you send it to, but these might very well and maybe should be. I think the next speaker will argue maybe they should be, more regional or near the edge or near where sort of tactical and operational decisions are being made, or maybe again it's with some of our partners across domains. So represented here centralized, but that's the beauty of a visibility fabric, is that it doesn't necessarily matter where and how those are located. That's our job, to make sure the right packets get to the right tools and teams at the right time. So I wanted to start and maybe spend most of the time here with just what I would consider a representative architecture of what that could look like. It's an out-of-band versus inline. There's really kind of two key types of deployments for visibility architectures. There's an inline, which means the tools that architecture is serving is in the path of the traffic. So think firewalls, IPSs, those sorts of devices. Those are a little bit more complex. There's a lot of philosophical differences on how you best approach kind of creating some of that resiliency. So I'm not focusing on that today. We do have deployments in enterprises, federal organizations, IC organizations, but the vast majority of them tend to be out of band, and there's a lot of overlap in sort of some of the fundamental capabilities. So I'll start there. You'll notice as I go through, there's really it's very much a software-defined networks. We're using purpose-built hardware and software to be able to control, get access to all of that packet data and control where it goes and in what condition it goes there. The first layer of that is the access layer. So this is going to be, how many are familiar with network taps, that concept? Yeah, a few? Okay. So literally this is tapping into the network, much like you would a keg of beer, right? You want access to it. You tap it in, get a copy of that traffic, and then send it on to the other layers that I'll mention in a moment, wherever it needs to go. From a Keysight perspective, one of the things we're really proud of is the breadth of our portfolio and these capabilities. So it doesn't matter whether you're using our what we call Cloud Lens capability to look at virtual environments, so VMware, KVM, whatever the case may be. Could be an and/or with multiple cloud environments, private, hate to use the word public, maybe in the gov environments, whatever the case might be for the cloud environments being used. It could be a physical tap, right? So copper and optical at various speeds and types. In fact, we were actually first to market with the commercial tap many years ago. We sometimes utter the words invented. I'm not sure if that's quite true from an invention standpoint, but for example, you will see if you look at the NCD SMO document on sort of best practices around implementing a cyber tap kind of scenario. It's actually a picture of our tap in that document. So very proud of our capabilities there. And then something that I think really differentiates us, and especially if you think about things like 5G and sort of modern warfare, where we can even look at some of the RF elements, right? So again, it could be 5G communication that are starting to be looked at and deployed now. It could be EW pulses, satellite communication, but the capability to sort of sniff what's going on in that signal, use some transforms, like for example, working with the VITA49 protocol, put that in packet format, and then get that on to, again, the right tools and teams to take a look at. So first layer is actually fundamentally even have access to that data to do the analytics. The next layer, and what I really kind of consider the heart and soul of a visibility fabric, is what I call network packet broker. You may hear me say NPV at some point, but this is what's really taking all of that, which you can imagine if you think about, again, the very diverse nature of deployments and operations and sort of the warfare scenarios today. Kind of data in different conditions, different sizes, could be 1 gig, it could be 100 gig, many different protocols, but taking all that diversity of data and then doing whatever needs to be done in that data to get it on the tools. And I'll come back to that more in just a moment, but the final layer are those tools and teams, and it could be network performance, it could be application performance, it could be big data analytics, and again, it doesn't really matter sort of the distributed or centralized nature of it. That's our job, to make sure it gets to the right place, in the right time. There's many types of tools, and some of them are overwhelmed. You've got in place, say, 10 gig tools trying to digest 100 gigs worth of traffic. We can filter that traffic and or load balance that traffic across multiple tools, right? Some tools like to have the header stripped because they'll choke on some of that information. Some want additional information and layers of intelligence that we can provide, VLAN tagging and some of those kinds of things where we can really just, groom that data to make sure that those tools are optimized, sort of turbocharged, if you will, and that the teams can really have the capabilities that they need to be successful and use their tool sets and analytic tools the most optimized way possible. So, as you can imagine, again, we're not doing a lot of the actual analytics, and the next slide I'll give you a little bit idea of what some of those more, I'll call it higher level capabilities are. But we're partnering with, I kind of put on the screen just a subset, right? But all of the tools that you're used to, again, focus here today is security. And so those are represented, but it could be network application performance as well. So we're there, what we consider tech partners. We have RESTful APIs for dashboards and automation partners to make that kind of seamless for whatever sort of deployment and kind of digestion that needs to happen across your tool sets and related teams. That's kind of the very basic, I'll say, reference architecture for the visibility fabric. It comes in all shapes and sizes and kind of varies drastically depending on the type of deployment. We have them ranging in size and scope across federal and DoD organizations, ranging from, for example, kind of a smaller flyaway kit form factor for cyber defense operators. Similar kinds of things with cyber defense operations platforms in general, maybe more full tilt, I'll say, monitoring systems and missions and operations, in the Army obviously, but across the DoD services, even Joint Command and some of the IC organizations. So again, we see a lot of different ways this actually is represented, but this kind of gives you a full tilt kind of view of what some of that might look like. I think it's important as you consider different options of deployment and capabilities, frankly, from a competitive standpoint, right? Like what you really are going to need not only now, but today. Some of that could be as simple as being able to scale from 10 to 100. We actually have 400 gig now, and on the test side of our business, we're already looking at 800, right? So that's kind of a part and parcel is being on the cutting edge of technology. I already mentioned the taps of kind of the far range of everything from cloud and virtual, physical, hazardous environments. For example, we have something called a tough tap when it's a little bit more demanding environment, over to even the RF spectrum. And then you can get to the layers 2 through 4, for example, where you're doing things that I started to describe, right? You're doing load balancing across tools, you're filtering out, maybe you want kind of moving to some of the more intelligent visibility, you want to identify certain apps. And you want to do things like send certain use of applications. Maybe it's video from a certain drone or a location you want to send to a certain team or certain tool. Whatever you want to do to actually specify what kind of data needs to go where and in what condition, that's some of the capabilities that really need to be thought as you're kind of planning that monitoring architecture, in this case, the visibility fabric part of that. It even gets into what I think be some of the more value-add and impressive capabilities around intelligence, application identification. That includes known applications. It could be, I'll say, Army or team-centric unknown applications, but we can recognize that it's a consistent application and deal with that, identify on it, filter it. Information like geolocation from a mobility standpoint, things like user and related application location session correlation, right, to see what's going on in 4G, 5G communications. And then, an interesting one for me from a security perspective is actually being able to do things like Ssl encryption and decryption. We know that a ton of the threats, ransomware, an example, actually goes through unencrypted traffic, and many tools can actually analyze encrypted traffic, and so you're sort of missing, a lot of the attack vectors if you can't even look at it. So we can do the SSL decryption and get that to, again, the right tools and teams to do it. And then finally, I'll just mention another good one, just where it's all about optimizing the team and tool capabilities, is things like early indicators of threat compromise. We're seeing things come from networks and locations that don't make sense, and we can kind of surface that for you and help you, deal with the traffic accordingly. The other thing I'll mention is tying all of that together is a consideration, like how do you view, again, this very disparate and distributed set of not only sources of data, but then where you want to send that data, and then being able to do that all from a single pane of glass in a very intuitive and easy to use format. I'll show that here in just a moment as I close. But also having, for example, the RESTful APIs and automation that enable you to really, I think, be interestingly effective with some of your tool sets. An example that I've seen is actually saying, hey, if one of my security tools sees a certain kind of traffic, I want to flag that traffic and that location from then on and start sending that to packet capture, maybe another team, maybe another tool set to then take additional action on, right? So those are all kind of capabilities at the higher level end of the intelligence that we can bring to the table. And then finally, as we close, and of course I'm glad to take any questions, but I wanted to, a little bit of a shameless plug, obviously we think we do it better than everybody else, but to put a little bit of form and function to why we believe that, there's really kind of three key areas I'd point to. One is, I already mentioned the broadest portfolio that really is just unmatched because of Keysight's history in test and measurement, but it's also that performance. You've got to have lossless, if you're dropping packets, the tools can't see it, and therefore you're going to miss security threats. And we've actually proven that in the lab with various tools and frankly competitors. The way we accomplish having this kind of screaming performance is, again, this purpose-built hardware-software combination and using the right tool for the right job, right? So we're using a switch ASIC for some of what we call net stack. This is some of the simple things like filtering and load balancing. We're using FPGA for these screaming fast, I also call it packet line rate manipulations or grooming, right? So this is where we're doing things like masking some of the data because you don't want it to be seen, or stripping headers, deduplication, all these sorts of things at line rate. And then, of course, we're using, the right tool for right job, network processor for some of the security and application work, and an x86 and crypto where that's needed. And then, so that's a performance factor. And then I think the ease of use, again, is just simply unmatched from a visibility standpoint. It's very much drag and drop. You can kind of see in the top right over there that it's just as simple as, hey, I have my sources of data. I want to drag and drop where I want those sources to go and what transforms in the middle that I want to do them. This is where you're doing your filtering, your load balancing, your application ID, whatever. And then the output of that to go to as many tools as you need it to. So one to many, many to one, however you want that to look like. So very simple, ease of use. And what it's doing under the hood is abstracting all of what I've been talking about for you. You can imagine if you've done any try to deploy any of these sorts of tools and networks and related rules around what traffic should go where and how, it gets very complicated. And the moment something changes with the tool set or the network, then all those rules have to be redone, right? We've abstracted all of that for you, and all you have to do is set what you want to happen and do the drag and drop activity to then see that carried out. Finally, I've already mentioned, but of course we have all of the ATOs to make sure that it's successfully deployed in these sensitive networks. So it's a little bit fast, but of course, glad to take any questions now. We've got some excellent partners of our TSI in the back. If you want to scan, we can follow up with you. Afterwards, likewise, our representative for Army, Barry, is in the back, and I'm glad to take questions as well. So any questions, comments? No? Yeah? Yeah. So the question is, can we do a lot of this in virtual appliances as well? Absolutely. That's kind of our Cloud Lens capability. So it doesn't matter if it's in cloud or in some of these, I'll call it virtual instances of various types. We can absolutely put the sensor there to get the data out of those environments as well. Thank you. All right. Yes. Well, thanks again for your time. Appreciate it. Hope you have a great trip back. Thank you. Yeah, absolutely.